People are concerned only because they haven't spent a lot of time thinking about what programming actually is, and they conflate it with the mechanical act of just typing code on a keyboard. But that's really not what programming is. Programming is the development of the recipe. It's not the actual cooking. It's actually putting together the right measurements and the instructions and the steps of a given recipe. We've had junior level people look up to us before. We've been training junior level people before. Our LLMs are effectively junior level developers. So I'm extremely excited.
Welcome to the /podcast, where we lean into the future of IT by inviting fellow thought leaders, innovators, and problem solvers to slash through its complexity. Today, we're going to talk with Mark Stahl. Welcome, Mark.
Thank you. Thanks for having me.
Mark has been writing code for over 30 years, 18 of those as a consultant, helping teams solve hard problems across industries. He's worked with everyone from Eglin Air Force Base down in Florida, right, to Apple, doing everything from mission planning simulations to building toy interpreters just for fun. Mark's a generalist with a knack for translating fuzzy business goals into clear, actionable steps for developers. Lately, he's been diving deep into developer tooling, making it easy for others to ship better software faster. I love that. Better software faster. Okay, I have to ask about the toy interpreters just for fun. That sounds adequately geeky, and I have to ask about that. Tell me a little bit about that.
When I was finishing up my undergrad in computer science down here in Savannah, Georgia, I fell in love with Lisp and consumed basically everything I could about John McCarthy's work. And that led me to basically say, oh, it's not that hard to write an interpreter. So what do I want to write? I also liked Smalltalk at the time. So I really was infatuated with syntax. I found the actor model with Carl Hewitt's work. And so I said, oh, the Smalltalk syntax and the actor model really line up well. And I dove into it and took about 3 months. I learned Go while I was writing it. So it was, which I don't recommend, by the way. I do not recommend learning a programming language while you're writing a programming language. It's a very bad idea.
I'm learning a programming language to write a programming. Yeah, that would be a bit of a tall test.
The reason I chose Go, though, is because with the actor model, I needed concurrency primitives. And so instead of having to write those, I just chose a hosting language in order to give me those for free, basically. I just had to manage the channels in Go. So it was fun. It was fun, except for the recursive descent parsing. That was probably the hardest problem I've ever solved. And then it's just like any math. It falls apart once you figure out how to solve the equation, and code comes out really easy.
Okay, so let's maybe do a crash course on the actor model real quick. What is the actor model?
So imagine that your program is how we experience the postal system in the real world, except for packages are actually delivered. So the endpoints are named. So you have person A and person B, or you and I right now, I'm person A, you're person B, and I say something to you and you hear it. So we have message passing going back and forth. Mm-hmm. That's effectively the gist of it. There is actually academic properties of the actor model that I don't remember off the top of my head, but that's what I was infatuated by, that it acted like the real world. We have these named entities on either end. They hold their own internal state, and they only access each other's state by sending messages back and forth. And I found that to be exceptionally interesting.
Now, you were implementing the actor model. Was this to learn how to do it and learn it more deeply, or you didn't want to learn Erlang?
I didn't know of Erlang at the time. So I didn't know anything about it. And I just also I thought that the object-oriented paradigm, the single dispatch of object orientation, worked really well with the actor model, because when you have object.method or object.message, that ends up translating really well to sending a message to, we see this with Objective-C. You send message to the object. So it was really just, can I do this? How does an interpreter actually work? And then the bigger goals were, if this actually works, can we start to model? Can we apply things that we know about the real world to writing software? Can I go to management theory books and
Mm-hmm.
start to apply those to writing software? And the big picture, the bigger picture was during that period of time, the Army had reached out to the Software Engineering Institute at CMU and said, how do we manage projects that are a billion lines of code? And SEI said, we don't know. That's huge. So let us do research. And they came up with this book. You can go look at it now. It's called Ultra Large Scale Systems. And they basically documented 7 areas. One of them was runtimes. And I said that we can't actually write a billion lines of code with the current paradigms we have. So what paradigms do we know that we can use? And the longest running system is the universe. So let's start with what we know about some physics stuff, and the actor model fit for that.
Very cool. And it's not that we can't physically write that much
Correct.
code. It's that we can't have the code actually work when we're done writing that much.
I would make the argument it's our limitations of understanding that much complexity. So how do you manage our source code? All the tools that we have are not suitable for managing that level of complexity.
Mm-hmm. Yeah, I first heard about the actor model we were doing I'm a Java guy, so Akka. And Scala and all. So I thought it was pretty cool. One thing I really liked about it is like, not only is the only way messaging, but it's kind of like a queue, right? So they only receive one message at a time, so they can serialize the updates to their state, so they can manage their own state very concisely, and they can control that very. So I love that. Thought that was a really cool model. Yeah, it's really it's interesting how many problems, if you sit and think about it, that you can actually model using the actor model. You got to get creative sometimes, and sometimes it doesn't work very well. But there are a lot of applications that you know once you dig in, you can really apply it. So pretty cool.
The interesting contrast would be to today's concurrency primitives that we use. Let's say specifically in Golang. I was going to write a graduate school paper on this, but that they're inverted. So the actor model has identity on either side of the anonymous communication channel, and CSP, or communicating sequential processes, which is what we have in Golang, is the inverse of that. So we have anonymous endpoints and a named, identified means of communication in between them. That's also first class, that you can pass around to functions and whatnot. So I thought it was very interesting that those two concepts seems to be opposites, seem to be inversions of one another.
All right. Yeah. So you sounds like you do think deeply about developer productivity and stuff like that. I know in your bio you mentioned that in the latter part of your career you've kind of gravitated towards helping other developers and building developer tooling. Tell me a little bit about that journey.
So that started with the language stuff. I realized that I liked writing software purely because I liked solving business problems. Because at the end of the day, when I graduated from high school, going into college, I did not want to be a nerd. I was a nerd my entire time at school. I did not want to continue on that. And this is before nerds were cool. So this was 1995. And so I wanted
to... It was a slur back then, right? Like now,
100%.
I'm a geek. That it's cool now.
Yeah, to like software at that period of time, you did not have a lot of friends.
No, exactly.
So I went into business school first and focused there. That's what I did, and then, but I was always writing software, and for the job that I had, just to make my job easier, which what technology is great at, finding inefficiencies in whatever job that you have and optimizing those out. So all of it became tools. After I got into the business of software, then it became, okay, how do we make this cheaper? How do we make this better quality? And spent my entire time in services. So where you have a time and materials contract, all the implementation is labor. And so let's see if we can optimize that to make our margins better. And that ended up being the focus, as well as the quality. We are flawed individuals when we write software, tons of errors. And it's not just typing that helps us fix those things, but things like read eval print loops where we can prototype fast and we can figure out
Hmm.
what we're going to write before we actually write it and have the compiler scream at us. So it's just a lot of interest in either making more money. Really, is what it boils down to, by increasing efficiency.
Very cool. Yeah. Yeah, I seem to have kind of gravitated towards that as I aged up in my career. I don't know. I think I did it all along, really. Early on in my career, I started working with like Apache Software Foundation and like building open source tools for other
Sure.
developers, like Apache Commons and those sort of things. So I always kind of gravitated towards building tools for other developers. Not that I don't like writing actual like business software, but I don't know. I just found maybe like you that I don't know. That's a cool vibe to be able to help others do their job quicker and faster and more efficiently.
I think there's something to be said for when you need a certain amount of experience in order to acquire wisdom, in order to have taste, actually to make good tools, right?
Yeah,
You
yeah.
can't just come out of the gate making tools. If you're doing that, you're doing them to solve your own problem, which you have to acknowledge that you have a problem, which means you have some wisdom at that period of time. So
Mm.
I think that it may be that as you get older, you focus a little bit more on tools because you actually understand what the problems are.
And I know you mentioned you've been writing code for 30 years. I mean, you're younger than I am, so you don't look like someone that has been writing code for 30 years.
Sure.
But like people ask me like, when did you first start coding? Like, I think I was like 7. So like, I've seen my first program was like Atari joystick
Oh,
and the
sure.
button, right?
Yeah.
Like typing in basic programs. That was oh gosh, hours and hours of that stuff. But what about you? 30 years, you would have been pretty young.
So I'd have been 15.
Hmm.
I'm 47. And that wasn't the first program I typed in. That's the first one I implemented. So the first one I typed in was, remember that Apple IIs came with a book with Apple Basic, and you
Hmm.
could type in the programs in Apple Basic to learn. I don't consider that to be the start because I didn't write that code. I just copied what
Right.
was ever in the book. I didn't understand what was going on. So in high school, I went to LaSalle, so in your guys'
Okay.
neighborhood, and sophomore year they had a basic class. You had two computer programming courses. There was a basic. We used GW Basic, so this is
Hmm.
where we had to enter line numbers, and so you always
Oh
did
yeah.
everything by tens, so that if you had to put a line in between, then you could do fives, and then et cetera. And
Hmm.
then the advanced course was Pascal.
Oh
Um,
yeah.
and I didn't end up taking the more advanced course, oddly enough, but I stuck to basic, and I ended up writing a menu system. Um, so it would drew an ASCII border around the screen, and then you had 1, 2, 3, 4, 5 in the middle, and then you'd press that, and it would go to a different menu. By the way, I did not know about finite state machines at that period of time, but that would have been a perfect use
Sure.
for so.
That's
um,
cool though.
it jumped from there after high school to programming MUDs in college, so multi-user dungeons. And
Nice.
depending on which type of MUD system you were on, you either had to program in C and then recompile the entire MUD, and there was downtime, or if you had something like LPC, which had an interpreted language, so you could actually build while the game was running. You could write monsters and everything, and it had an interpreted language called LPC, which the modern implementation of that is a language called Pike.
Okay.
So it's a C scripting language basically. So that was the first experience mostly.
It's so funny how many, when we interview people to work at Calibrity, that's one of the things like, how did you get into programming? That's one of the things we ask people. And well, I always liked video games. It seems like
Sure.
that is a big like avenue for people to get into our industry, which
I meet with my former dean of computer science almost every week, and the one of the big things that I see students now lacking is that they don't actually know how a computer works prior to getting into the computer science department. And I remember is that like we didn't have laptops with unibody cases and a single main
mm,
board. You had to go build the machines, and you had to figure all that stuff out. And there was a certain amount of you had a certain amount of expertise because of that.
right.
Now, I, I don't even know. I don't know how these kids are doing it. How do you figure out what program you're going to write? Um, I don't even know how that begins nowadays. It's very, but nonetheless, they should be building computers. That's what I tell everybody. Go out and buy pieces and build a computer. You need to understand how it all fits together.
And nowadays, it's like an art form too. Have you seen some of these
Yeah,
rigs
yeah.
these people are building these days? They're beautiful.
I mean, I'm not fancy.
It's
You
so
can see behind me.
fun.
I'm not fancy at all. So, like, I don't get into that. I'm purely pragmatic in that regard.
But it would be. I mean, I've seen some of these videos of some of these builds, and it's like all these lights and side of the case is clear and everything. Like it was like building PCs back, when I was younger. So, yeah, that's cool. Do you have to take like the assembly language that we had? It wasn't just called assembly; it was like computer architecture and
Two.
assembly or something like that. Did you have to do that?
That was architecture. That was Arc 2 is what the shorthand name for that
Okay.
class was. Arc 1 was, doing adders with gates and whatnot. And I by the way, I failed that class 3 times.
Really?
Yeah, I'm terrible at the low level stuff. I'm absolutely terrible at it. When I got to Arc 2 and I could do assembly language, I was okay. I understand registers. I understand the stack. I understand a program counter, all of that stuff. But the Arc 1, terrible at the gates. I am absolutely, it is like
all the ands and ors and XOR gates and all that stuff.
But I'm good at symbolic logic. I'm good at Boolean algebra. I'm good at, I can do all the truth tables. It was applying those things to the gates for some reason. Just my mind did not grok it at all. It was very bizarre.
So I won't mention names, but we had a professor. He taught the assembly, and assembly's kind of dry, right? I mean, it's not like you're not excited by assembly language, right? It's not a real, jump out of your seat kind of a thing. But this guy was like the dude from Ferris Bueller, Bueller. He had like that monotone and just draw
terrible.
on. It was so bad. It was awful. The guy was fantastic. He was very knowledgeable, but he just had a way of talking it was very much like, Ferris Bueller's Day Off. That's what I thought of every time. I'm like, just get me out of this class and let me just do the homework.
Right. Sure.
Yeah. One thing you mentioned, you didn't take any courses on like computer science history.
Nope.
And that was kind of an interesting thing and I hadn't really necessarily thought about that because I do that now. Like I read about those things now, but I didn't really have a lot of courses on the history of computer science. We'd get anecdotal things about Euler cycles and stuff when we did the bridges of Königsberg and all of that. But like there's nothing going through the history of computing. So do you see that as an issue in the industry today?
100%.
That there's a lack of it?
Sure, because if you look at, I'll pick on JavaScript developers here just because I spent the last decade being a JavaScript developer, so I'll pick on these guys. Our industry is driven by fashion, and you can actually see it's very prevalent right now with the AI hype that's going on. So we are fashion oriented. It's always this is something new, et cetera, et cetera, et cetera, and rarely are we saying, you know what? There's a ton of smart people behind us. We should probably go back and see what they were talking about and see if we can apply any of the skills because then we don't have, like, if developers were truly lazy, which we claim to be, that's why we write software, then we would be going back and going, whose work can I steal and apply to my modern problems right now? But I think that the creative drive overrides the laziness so it is a desire to have an open source project and put your name on it as saying, I created that, even though it's the same thing that someone else did 10 years ago.
Right.
So, I didn't get into history in general until John McCarthy and looking at Lisp and finding out that we had garbage collection in 1959. To where we had John McCarthy calling John Backus, the creator of Fortran and the creator of Backus Noir Form, which is how we specify parsers, calling him and saying, hey, we did this cool thing in Lisp called a conditional. And I think it would be really useful for Fortran to have one as well. So we got if statements in 1959, 1960. But I mean, there was obviously precedent for that in the assembly side of things because you had jump if zero. So jump if false. Anyway. But that led me to say, okay, it's now 2002, 2003, and here we go with garbage collection created in 1959. What else am I missing? And so that led me to Douglas Engelbart finding out about the demo, and you get to see the Stanford guy demoing the mouse and a WIMP interface and whatnot. And I'm like, holy crap! There's tons of smart people that we need to be pulling from. And that's usually my first avenue now, is even with this AI stuff. I was like, all right, let's go back and check out what the AI winter people were doing at that period of time and see, because we had Lisp machines, and those machines have some of the best operating systems and the some of the most efficient means to interact with the environment, the programming environment that I've ever seen.
Yeah.
And so what can we learn? And what's missing? Why aren't we doing that now? Those sorts of questions.
I think I love that you like that is it creative or I don't know how you phrase it, but the drive, like us developers. Okay, yes, I know that someone else, and the ORM is this is the classic one that people will do, right? You know, it's like, well, of course there's ORMs out there and people have already done this before. I'm going to write my own. Everybody, when you're 20 something, you're like, I'm going to write my own ORM for this project, because how could those people be smarter than me? Why are we like that? I mean, I think are we natural like problem solvers and kind of puzzle, we like puzzles. So we want to figure things out and it's just stimulating to our brains. I don't know, but you're right. I mean, it'd be great if we could if we would streamline the evolution of computing so that we didn't have to kind of go back and relearn all these things again and go through the exact same problem over and over cyclically like that. It's fascinating.
I think there's a catch-22, and that is, for example, we don't know the recipe for Roman concrete, for example, right?
Right.
So I think that the going back and recreating is actually a fundamental part of the creative process that we kind of need how do you learn? More specifically, how do you know what you don't know if you haven't actually solved the problems? You don't know what they went through, right. How they failed, etc. So you go solve the problem. You're like, oh, that's why we don't do that. Because that's I end up hitting this wall. So I think it's part of the creative process. But I guess my issue with it is that people don't acknowledge the past. If they came out and said, I'm doing this because I want to learn how these algorithms work, and I want to know, nobody's documenting their failures in the code, right? They're documenting their successes because that is a working piece of code. So we don't actually know how they failed. And when you're learning something, failure is the best teacher during that period of time. You get smacked in the face by the compiler, you get smacked in the face by your customer, et cetera, et cetera. So I think it's important. I just wish people would acknowledge that, hey, I learned this from this paper, or I didn't know about this until I listened to Carl Hewitt talk on a MSDN video about the actor model. And I said, so it's really cool. So let's do this.
Yeah. Well, I'm guilty of it. I mean, I'm taking a course on deep learning on Coursera, and of course, TensorFlow and all those things are out there, and I could just use those libraries. But no, what do? I write a library that builds neural networks.
Sure.
Just so I literally did it to understand it. It's a learning tool for myself. But I'm sitting here critiquing it. And I'm thinking to myself, I'm doing the same darn thing.
Exactly. and that's a learning process. You're not going to actually learn. And I'm sure we'll get into this when we start talking about development with AI. But when I worked at a previous consulting company, one of my isms would be that the problem with developers is that they like to write code. So because we would have business cases that it would be good enough for the business case. And let's say that the customer was happy with it, but the developer would be like, but no, it's not technically correct. We need to have it to be, it's not good enough. And I'm like, no, it is actually, because we need to move on to other things. We do need those developers where they just like to write code, and just writing code. I mean, you have to that includes re-implementing what's already been implemented.
Lately, all the fad was single page apps. You're doing all of your rendering in the browser and all this stuff. And they would be like, oh, that server side rendering you old folks do. That is so passe. What were you thinking back then? And now there's we're coming back around to server side rendering again. And it's like, what?
Yeah, I
for
remember
like
this.
a
It's called
decade. I listened to
CGI.
it. Yeah, for a decade we listened to everybody telling us we were like old fogies because we, servlets and JSPs and those sort of things, like and MVC patterns and all that. Like server side rendering was bad, and no, you need to be doing single page apps, and now we're coming back around to server side rendering. I'm like, okay, fine. Well, I mean, just dust off the old libraries.
Yeah, the
We'll do this
PHP
again.
guys feel fully justified.
Oh, absolutely.
They're like,
nailed it.
You'll be back. You'll be back.
Yeah, exactly. Yeah.
It
Unfortunately,
is,
they spent all those years trying to do the other stuff too, and they should have just stuck with what they were good at.
yes.
Yeah, it's so silly.
I think there's also touch on an interesting point there. There's also a certain amount of religiosity that goes into where we're all in on a given technology, and that could just be human personality types where they get involved in the hype. I'm not much of a team spirit sort of guy, so maybe I just have an immunity to that sort of thing. Because I don't care about a given team. I don't care about a given any. So it's very interesting though, just to be all in on one given piece of technology. Like single page apps are the future. This is not going to change. Except, oh wait, we're gonna render stuff on the server as well.
Yeah, sometimes it works better when you do that. It's a little more secure if you do that. Yeah,
it's very funny.
And I think there's a place for everything. I personally do like writing single page apps. I do like writing in React and those sort of things. But there may be, there's a place for everything. So
I usually do single page apps if I have the choice, because there's a level of complexity by adding a back end to the whole thing. I could just write in JavaScript. All the testing is very easy to do. Mm-hmm. I could deploy on Cloudflare, super simple, and just do refresh, and everything just works, and I don't have to set up a server. I mean, there's some niceties to it, but yeah, whatever. It's welcome back to what we did in the past.
So we didn't really talk about like going down this path, but I would be interested to hear your opinion. There's in our industry for a long time there was quite a bit of like pedigreeism, right? Everybody was like, "Oh, are you a Carnegie Mellon person? Are you a classically trained computer scientist and all that?" And so they kind of overemphasize on that. But there's lately I don't think we've ever had like a plethora of software engineers where we're like, man, what are we going to do with all these folks, right? That's never been the case. So the boot camps started coming out, right? So when you have 13, 15
learn
program
to code
and learn just to code, and don't you don't learn the history of computer science. You don't learn all the ins and outs of all the things that we had to do, sorting algorithms and all that stuff, big O notation. You don't learn any of that stuff. But argument can be made. I don't really think about big O, at least not consciously, on the job writing business apps. Right? I'm just focused on a lot of the surface level stuff for the most part. What do you think about that? What do you think about that? Is it okay? Is that going to work? I don't know. Where are you on that?
So it's funny you say you don't think about Big O. I literally had a Big O conversation 2 days ago about solving a problem and I'll tell you a little bit about. We're storing metadata on these entities in this application, and we're using Oracle 19C that doesn't have any JSON primitives in it. So there's just a blob in a column. And it's okay if I want to do a search, and let's say it's a Splunk style searching. So or just a space separated key value pair with an equal sign in the middle. Well, what do I have to do to find all of the entities that match that metadata? And it's like, well, I have to go find them all in the database. I have to unmarshal all the JSON for each of the metadata. Then I have to put them in a collection, and I have to iterate over them, checking each key value pair. And that's O of N at the very, right? And I was like, that's terrible, because as this goes, we could have thousands of entities, and then each one of those could have hundreds of metadata fields. This is a problem. So actually it's O of N squared, because you have O of N and then the entities, and then you have the metadata inside itself. Right. So I actually do think that that's a at least that the performance characteristics of a given algorithm, I think, is important. And we, from the customer side of things, I could not change Oracle. I couldn't use something like Postgres where I could have Postgres optimize those JSON queries out.
Right.
So we had to pull it into the backend is written in Go. We had to pull it into Go and do it that way. And so what we then have to do, if I was naive and I didn't necessarily understand the performance characteristics of a loop within a loop, then I wouldn't necessarily know, okay, well, we need to figure out how to assemble this into the storage trade-off as opposed to the CPU trade-off, which you wouldn't even necessarily know to talk in that language. Those are the two trade-off characteristics if you didn't have, let's say, a data structures and algorithms class. So I think that I'm not interested necessarily in someone having a degree in computer science. I am interested in someone giving up free time to spend time on the thing they want to do for their career. So I think that that's the important thing, is that you have to have the passion enough to give up other things to spend time looking at these, let's say, performance characteristics. What's big O? Nobody ever talks about big theta or anything like that. So what's big O of this? So I do think it's important, but I don't think pedigree is important.
What we've found in our recruiting process, and as we, hire developers, it's not really about how many languages you put on your resume. It's not because of that. It's because of the inquisitiveness and the yearning for that learning, right? And the people who do good, tinker on the side, those sort of people that have that drive, the problem solvers, the people who just love, they sink their teeth into a problem. Those kind of folks. Those are the people that they'll figure out the language. They'll go learn Go. They'll go learn Lisp. They'll figure it out in order to crack the problem. The problem is their drive, and and the other things they're just tools to get there. So that's been the thing that we seem to over-index on, and it seems like a better indicator for success.
What I thought, when was the learn to code thing? Was that 10 years ago?
Sounds right.
Something like that, when we were telling miners, like, no, stop mining and go learn to code. And then I had the problem I had with that was people, it made it sound like a lottery ticket. Go take this boot camp, get a 6-figure job, and everything will be great. Well, these people aren't going to get 6-figure jobs because whether we like to admit it or not, our industry does command a given mindset to be good at it. And not everybody's going to be good at it. I am not the best developer in the world by any stretch of the imagination. But I have social skills. So you're only allocated 10 points. So.
That helps. That puts you over the edge. You got to be a little crazy to sit in front of a computer all day. You do. Yeah. You kind of have a little bit 100%. Of something loose up there. I think there's definitely a type. Anybody can learn the syntax.
I had
because I've always heard people say anybody can learn to code. Yeah, you're right. Anybody can learn the syntax, but I don't think people. You have to like enjoy it to stay deep down in flow, right, with the problem for sustained periods of time. If you don't enjoy it, you aren't going to excel. I mean, you can learn the syntax, but you're not going to excel if you can't stay down in the code or down in the problem like that. And you just have to enjoy it to do it.
And where you must solve the problem.
Yeah,
you must. You can't. It's not a question of if you can solve it. You must, and I will not leave this chair until I've solved this problem.
It's like an obsessive compulsive kind of thing. It's a level of that. Absolutely.
I had a philosophy professor. So that, by the way, I'm a big proponent of introducing at least intro to philosophy into any computer science program as well, because there's very few programs that have as much abstraction that computer science, which is a branch of mathematics ultimately. So math is all about abstraction, and philosophy is the other one that is really all about abstraction. And it's really good because it teaches you how to ask good questions. You don't go, everybody thinks that philosophy class is about finding answers. It's not. It's about asking good questions. And that's really what you need to be able to do to be successful in our field, is you need to be able to abstract, and you need to be able to ask the right questions to abstract. But he was going to go into computer science, and he was doing his senior project, and He went in to the lab at 7 a.m., and it was a Fortran project, 7 a.m. And when he remembered being done, it was
Mm-hmm.
dark outside. And he said, I have to quit because if I don't, I will lose my life effectively because his life will be, he was so
Mm-hmm.
obsessive compulsive that he would just lose days. And he was like, all right, I'm going into philosophy. That was his father was the chair of
All
philosophy
right.
at Mercer. So he had background in that already, but he wanted to go into computers. So it was interesting.
So, people like you and I have, or like you and me, have studied all this stuff for all these years. And then along came the LLMs. What do you think, man? What's going to happen to our
Sure.
industry? What's going to happen to people like us?
I was initially very bearish because even at this current stage, it's a glorified
Mm-hmm.
autocomplete. Let's be
Mm-hmm.
realistic here. And it turns out to be a really good autocomplete, but that's that's really what it is. So, and I said, I've been doing this a long time. There's a lot of nuance and complexity in what we do. As I thought about it, so it's been quite a few months that I've just spent thinking about it. Now I'm on the bullish side, and I said, "Yep, I think this is." Again, I made a comment earlier where technology is really good at finding inefficiencies in markets, and I'll use a very hyperbolic term, eradicating those efficiencies with extreme
Mm-hmm.
prejudice in many cases. And I think that's what we are right now. People are concerned only because they haven't spent a lot of time, I think, thinking about what programming actually is, and they conflate it with the mechanical act of just typing code into a on a
Right.
keyboard. But that's really not what programming is. That programming is the development of the recipe. It's not the actual cooking. It's actually putting together the right measurements for and the instructions and the steps of a given recipe. So we see this, as you had said, we're both older. So we've had junior level people look up to us before. We've been training junior level people
Mm-hmm.
before. Our LLMs are effectively junior level developers. We have to tell them what the requirements are. We have to tell them not only what to implement, but to how to implement it. I need to tell you what file you're going to create. Here's the convention that we use at the company for naming our files. Oh, no, don't name the function that, name it this instead, because that's more clear. All of this is just like interacting with an LLM as far as writing software. So I think so I'm extremely excited. I think that at the end of the day, we we will lose jobs,
Yeah.
but those jobs will be the individuals that we just talked about, where are not really good at their job. They were the learn to code people that didn't really have a passion for doing it, um, and they're hiding amongst maybe large companies. Um, the the senior level people like myself, like you, it's more to programming than just typing on a
Right.
keyboard. The problem solving that you do on a whiteboard, the design, the requirements, all of those things, an LLM cannot do because it can't do creativity.
But if you pull that thread, you keep pulling that thread, it gets really, it can get really interesting. So prompting is kind of like we, what we've been calling all along in computer, engineering or software engineering requirements, right? You're giving the LLM the requirements of what you want it to do, and you have to get very explicit in order to get it to give you the right thing. Are we just entering into another world of like where we have to be very good at requirements again and explicitly telling it, and then the mechanics of
Yes.
keyboard, and let the machine do that part that we, us humans do now. Let it do that part, but we still have to, as you were saying, get down into the problem and understand the user and have the empathy for the user and what they're facing in their life, and how do we make that better? Is that kind of where we're headed?
So first off, let's say that should be a happy future for us because that means I'm not going to have a massive case of arthritis when I get older in my wrists and my fingers, right? So I'm all about giving up the typing. But yes, I think to put it from a, let's say, a business perspective, I think the cost function for implementation will collapse to close enough to zero to be effectively zero from a business perspective. What we will end up having to focus on, because this is I had spent a lot of time focusing on the requirement side of things. I'm gonna name drop here. So the All In podcast, Chamath
Yep.
Palihapitiya had made a comment about the QA process. So this is what's really nice about this, is that it kind of bookends when I was looking at the requirement side. He had made, and this is a great point, that we're going from a deterministic means of doing something, writing this code, this feedback loop, to a probabilistic system. So I think in the 4 phases of software development, even whether we're talking about agile or anything else, we always have requirements, design, implementation, and test. That was the case in the waterfall process. That's the case now with agile. We just do it in a higher frequency. We're going to end up collapsing the implementation. And so we're going to have requirements, design, because we're still going to have to figure out what the problem is. We're still going to have to try to figure out, all right, what, let's say, patterns are we going to use to actually implement this software? We may not actually do the implementation. We just may communicate that via diagrams, via text requirements, et cetera, et cetera. But on the other side as well, because a computer, a machine, an LLM has no authority, we're going to have to QA it. And I think that will, when we say QA, we kind of think tests, whether those be unit tests, whether those be human tests, point and click. But I think it's also the peer review process. So the LLM is going to give us a diff of what it thinks it should change. And we're going to go in and say, you know what, that's a bad name. Let's change that name. And we're going to be pointing at specific lines and saying, nope, we're going to change that to this. This, again, going back to the junior developer comment, this is exactly the same thing that would happen.
You're doing like a pull request review kind of idea.
Yeah, exactly. We're gonna sit over the shoulder of, or if we're in the same office, we're gonna get together and we're gonna go line by line. Nope, that's a bad change. Let's change this here. Oh, that's really good. I like this. Maybe we save that for later. No, let's not do that loop. Let's do a do while, because we have to execute it at least once in order for. So those sorts of things, I think, are what developers are going to end up doing. So we're going to write the requirements of the design, because we need the brain of us to articulate how these things are going to be put together. The mechanical aspect of actually typing out code, again, it's a language model of execute. That's going to be done by a machine. It's going to be done really fast. But then we're going to have to come behind it and say, oh, that's garbage. We're also going to probably have to go back and check our requirements, because garbage in is going to be garbage out. So it's a very interesting time that we're going to get into, and I think it's going to be, we're going to be able to pull from a lot of history and say 30 years of software engineering, of requirements engineering. We're going to be able to go back and look through that and go, okay, how do we do this? How do we properly communicate to the LLM?
I've been waiting for the right guest to have this conversation with, but so let's pull the thread further.
Okay.
Let's pull it just a little more. Right? Our sweater's not gone yet. Let's keep pulling this thread.
That's right. Weezer comment. Okay.
So you said, "Oh, that's garbage. the code is garbage." But how we've been trained through many years of seeing good and bad code is based on, a lot of it is about, is it readable? When I look at it, is it doing kind of what I expect it to do? As Uncle Bob says, good code is, when you look at it, it does what you'd expect it to do. But if machines are editing the code themselves and generating the code all the time, why does it matter? If a human being doesn't really need to read it, why does it? Does the concept of good code change?
I think when I'm speaking about it at this period of time, I'm looking only maybe 6 months to 18 months in the future. So I'm still a little bearish on the output of LLMs. So I imagine that I'm basically saying 6 to 18 months. There's still a lot of hand holding.
Human in the loop type.
That's right. That's exactly right. So, but as these LLMs get trained with better data, and they end up becoming more efficient, I'm not sure that the quality of code is going to matter, aside from the physical constraints that we have all the time, which is CPU, memory, et cetera, et cetera. Because now the question is going to be, The machine still has to read the code. It's effectively garbage in, garbage out. I still think there will be a concern for that. I still think, again, if for no other reason, computers do not have authority. So, and we need to keep that always in our mind, is that you're a machine, you do not have authority, you work under my purview.
Right now we're talking about the output of a machine's output. If you take the analogy of like business people today, like what we have today, traditionally in software engineering, business people say, I need a piece of software that does this. And they come to people like you and me or a business analyst and they say, okay, I'm listening to you. I'm hearing what you have to say. I'm interpreting your language. And I'm saying, I think this is what this means in some other language. We're a transpiler, so to speak, right? So I'm taking human language 100%. And I'm transpiling it into Java or Go or whatever. That's what we do. We take the place of the LLM. The language looks pretty foreign to like if you ask a business person to read Go, there may be human, there's going to be English words in it, but they're not going to understand it very well. They may understand it to a degree, but not to the level that they would need to in order to work with.
What is this colon equal thing?
Why is it equals here and colon equals other places? That still bugs me with Go. All right, so let's take that. Now the LLM is taking the part that we used to play of interpreting. Human beings say, I need this. LLM says, okay, I know how to translate that into something that a computer can understand. Well, it was a multi-step process before. So it was human beings to human being. We would then interpret that and say, okay, we're writing source code, 3GL, those sort of things. But then we also had a compiler that would take that and turn it into a machine. Why can't why not go away with programming languages altogether completely? They can go away forever because why doesn't the machine just write machine code?
It depends on what the training data.
I mean, it would have to be able to do that, obviously. But like, there's really no need for human. If we're going to turn it over to them, there's no need for a language, a human readable language.
No, it all just depends on the domain. So that would be the means in which I would pick a language. So if I'm writing for a browser, let's assume that WebAssembly is not prolific and ubiquitous amongst the browsers, then we're going to write in JavaScript. If I'm on the back end, now with the large language models, I will caveat this: I am not a typed language person. I'm actually a very dynamic language person because I have a certain amount of discipline. So I like the speed that I get with, and I hate a compiler yelling at me. So
I'll get to it.
Exactly. Like that's my one big beef with TypeScript is that I like it, thank you, but I'd really like to prototype this right now. So stop screaming at me that the types aren't there. It's really obnoxious.
Do you remember the old so if you like Smalltalk, Visual Age, remember those IDEs? Yep. It would compile as you go, and it would like complain at you, so you couldn't 100%. Just like flow with the code and type stuff. Anyway, that was an aside. I hated that.
Remind me to bring up the Smalltalk reference of saving the image again because there's a good story. So I think that typing is actually going to be really important from the LLM code generation perspective, only from the fact that it is a feedback mechanism to the LLM. So so it's like I wrote this code and the compiler fails. I get feedback from it. It tells me what's wrong. And that feedback loop I think is exceptionally important, especially for reasoning models. So that's the language itself doesn't matter, but I think the feedback loop matters more.
Yeah, it was interesting. We had a client situation where we're speaking with a client about a problem. They have some software that's in kind of an antiquated language, and there are people, not a lot of people in existence that just on this earth that know that language anymore, right? And
sure,
it was kind of mentioned like, well, now that we have these LLMs, well, why don't we just, instead of like translating that old language thing into a modern day language and let's maintain that code, it was like, just leave it where it is. Let's just let the computers maintain it for us. We're not really doing a whole ton of new features and stuff. Why don't we just leave it where it is? If the machines don't know how to understand and edit the language, fine. we come up with a situation where something breaks in the middle of the night. We tell the machine the context. Hey, here's what the users are seeing. Blah 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 blah. Oh yeah, I'm looking at the code. The machine says I know how to fix that. Boom, fixes it. It's done. What do we care? Interesting. It's an interesting
Yep.
idea. I don't know if highly regulated environments would allow that, but
Sure. And also how much of the training data includes that language.
yeah.
So that would be the problem with the obscure languages. Like, let's say, for example, I'm a huge Common Lisp fan. I'm probably not going to get very good output of an LLM for Common Lisp because of this. Not many people use it. I'm going to get great output for JavaScript. I'm going to get great output for Java. And there's C, C++, because there's nice code bases, actually very well written code bases that I can feed it in and say, here's what you should look at. So I think there's going to be some very interesting takes. I think there will be a lot of personal training for those things. I think will go away eventually, especially on the only speaking about the code generation stuff. We'll go away from the large language models. I think we'll get to the point to where we will have language specific. I can curate a list of projects. Maybe they're even internal to our own code base that I can feed and as training data, so that we can provide, let's say, company specific context. Or if it's a C output, maybe I go grab things like SQLite and really good, maybe 0MQ, really well documented, really well structured code bases, and I feed them into a system. And so I increase the quality of my output. I don't know. I'm not on the research side of things, but I think that is a possible future with this sort of
What
stuff.
do you think about with these, not necessarily LLMs, but some of these models, these we'll just call them AI models in general. They're very big. They have a lot of parameters. It takes a lot of, if you are training them, it takes a ton of time and a lot of money and a lot of compute. But also, even on the inference side, once you have trained it and you're ready for it to start doing things for you, that still requires quite a bit of compute. With you're transforming large matrices and all those things. How are companies going to deal with that? And are running all these things and having to now understand this how to care and feed for these type of things. How are we going to deal with
that? So I think in the prep call I used the term fabless, which requires some age to understand the context of what that even means. Maybe even it's so niche of a context, even some people where they're older won't understand it. But in the late 90s, mid 2000s, we had Intel, NVIDIA, AMD, etc. They all moved their chip manufacturing out as a core business. It was no longer a core business. They subbed it out. This is why we get TSMC, for example, in Taiwan. So effectively, Intel, NVIDIA, AMD, they're all design houses. They really just design the chips and then send them off to a fab to be manufactured. I imagine, and we kind of have that for hosting of services now. We have AWS, we have GCP, we have Azure. Before that, we had colos and we had VPSs, virtual private servers. I imagine the same thing's going to happen. The capital expenditures that are going to be required to, whether that be from a power perspective, whether that be from a cooling perspective, whether that be from a GPU perspective, not a lot of companies are going to be able to suffer that. Yeah. So I think that there are business opportunities for VPSs for models to where they can offer me compute. I can go in and train them. I may have people on staff that know how to train models, just like I have people on staff that know how to write software. Or I may come to a third party, a consultant, and say, I need this stuff done. And that consultant says, we have a great model for TypeScript that's going to generate amazing code, and therefore that's going to decrease the cost of implementation. I don't think everybody's going to have necessarily a model. Or if they do, they don't care about the time it takes to generate code.
So you think
I could see...
the economies of scale. Well, just the reason AWS is successful is because they can put 500 people's data center in one building with one cooling system and one, in pipes in and out and all that stuff, redundant power, as you were saying. So those economies of scale, same thing, but just for model hosting. So instead of, business workloads, it's AI workloads that are being.
It's just compute.
Yeah.
Why is it any different than a Lambda function?
Yeah.
Right. It's data in and it's data out. There's not much difference. So it's I could see as well though to create an XKCD comic where life imitates art and art imitates life. I could see that me having a model on my machine, maybe hosted in a Docker container, that I'm typing out requirements and I'm typing out design, and I push enter and I go walk away and make lunch.
Yeah.
And this used to be our reality in 90s and early 2000s, right? This writing in C++, and then we'd hit compile and be like, all right, I'll wait for that to fail.
Time for lunch, come back. Coffee. Got some laundry I got to do. Yeah.
And for the listeners, the reference is the XKCD comic where code is compiling. Go look it up if you don't know what I'm talking about. But it's two developers sword fightings on the back of chairs, and the manager yells at them and said, "What are you guys doing? Why aren't you back to work?" And code's compiling, and that used to be our reality.
Yeah. Oh, absolutely. Yeah. We didn't have like 3-second build times back in the day. It was hours.
And that's even long.
Yeah.
That's long. 3 seconds is a long time.
Yeah. Well, I mean, like with tests and everything, like full test cycle, build, compile, all that stuff. Like we can be in production in 3 seconds with some things.
I'm so spoiled that I get so angry with CI running, because I'm like, this takes way too long. Why does this take so long?
I'm such a geek. I started like for my side projects. I run them on GitHub as GitHub Actions, all my builds and everything, but like it doesn't really run there. I have a little Linux server at my house, and I'm like, this is my runner, because I get so sick of like they're not as fast, and I'm like 3 times as fast running out of my little Linux server that's here at my house. It is like so much faster. I have no patience.
Time is money.
Yeah, time is money. Yeah, this has been awesome, but we're going to move on to Ship It or Skip It, and I think we can probably get into some interesting topics in Ship It or Skip It that kind of touch on some of this stuff.
Ship or skip, everybody, we got to tell us if you ship or skip.
What about killing the keyboard, voice-based coding? And what I thought of when I was thinking about this was like Jarvis. I bring this up a lot. People who listen to the show don't hear. I've mentioned the Jarvis thing a lot of times, but like, Iron Man's like, "Hey Jarvis, blah 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 blah." Oh yes, putting that together for you now. So will we be doing that? Like right now, we're typing into a keyboard. Even with LLMs, we're typing most of the time. I do interact via voice. But what do you think? Think that's how we're going to code in the future?
I think that we will articulate voice for requirements design. I do not think we will articulate source code via voice. So we will articulate, here's the functionality I want you to build, and here's how I want you to build it. And then you will ask me any questions if you need further clarification. But I don't think we'll be like, if, open parentheses, blah, blah, And
I don't think it'll mechanically, no,
that's so terrible.
But you could say iterate over these things and just give me the first name of all these objects. You could do it and generate that.
I think that's completely possible. I have a little app I wrote for myself, so when I'm out walking the dog, I can make a phone call. The service picks up on Twilio, and I just start talking. It tells me to start talking, and I'll use this as a brainstorming session. And then when I hang up the phone call, it will get transcribed. It will get summarized, and then I'll get any action items coming out of it as well. And then that will get texted to me with a URL that I can open up, and so I'm most likely going to add that to where it'll email a certain email. So it'll go to make.com, for example, and then I can extract all of that information and maybe turn it into, summarize this, reorganize it because my thoughts are a little bit all over the place sometimes, reorganize this into a blog post and email it to me again. And so that I have content. I talked through all of this stuff. Now I have content to go in and fill out, but I don't have a blank page. The phone thing was important for me, using the phone, because I don't like apps. I don't want to develop an app. I don't want an app on my phone. So just making a phone call was super useful for me.
I love it. Musings with Maisie. Blog posts from walking my dog. I don't know what your dog's name is, but I just made that up. That's cool. All right.
He's so weird. His name is Whistle.
Okay.
Whistle.
What is it? Whimsies with Whistle. I don't know. I'll come up with something better for you.
Whimsical ways with Whistle.
Yeah. All right. So voice-based coding. You're skip it, or probably coding skip it, but
I think coding is the wrong word.
Yeah.
I think we already know transcribing. I say ship it. We're gonna end up articulating requirements and design via voice.
Okay. And I had this idea. I didn't get this from anywhere, but it kind of came to me as I was like researching for ship it or skip it. So what about what if you use AI to kind of AI driven TDD, test driven design, right? So what if the AI does the testing up front, and then
Sure.
that's almost like a context for itself. Like, okay, we hone into all the cases, the edge cases that need to be covered, and all of that sort of stuff, and then the AI generates a test case. Now it's the context of like, okay, feels like a good test suite, covers all the cases. Go make the code that makes this green.
So again, this is another one of those nuanced things. I think it's the wrong question. I'm not a big fan of test-driven development because at the end of the day, my tests should cover the requirements, not cover the code, so to speak.
Mhm.
So I would say writing to the requirement and getting a constant feedback of failing. So as it's writing the algorithm, it's also writing the test. But at the end of the day, to meet the requirement, not necessarily to get a green light on, because that's the TDD thing, right? Is it I'm going to write just to the algorithm that I'm doing. So I would say yes, write the test to meet the requirement that I give it, not necessarily to meet the structure of the code, because I believe that's fruit of the poison tree. Basically, we're writing to the thing that could be broken, as opposed to writing to what I'm trying to implement.
It's like the wrong premise.
I think it's the wrong premise. Yeah.
So this one's kind of related. I was thinking about this, and I think we briefly touched on this in the prep call for this episode. But could IDEs, like our integrated development environments, what the things we hold near and dear to our hearts, every day we live and breathe in these things, are they going to evolve to be more about honing requirements over time, and then just like we were talking about, the mechanics of spitting things out? Like, are we going back to rational rows? You know what I mean? Like,
no.
Are our IDEs really going to be about, here's the problem, here's what I'm trying to do, here's the requirements of this situation, and then the IDE helps me hone that, and I work on that, and then the output is just the code.
I'm actually working on a project related to this. I don't necessarily call them IDEs, but requirements elicitation tools are going to make a comeback. And rational rows, that you make a mention of it, that was a diagramming tool, but that IBM purchased when they purchased Rational Software, and they subsequently purchased Doors, which is the big requirements thing, and that's now under the Rational banner. Everybody hates it, so I'd love to compete with them. So I think that so here's a problem that I'll articulate. So I watched a video from the VS Code channel, and this was talking about the new changes they've made to Copilot. And the guy's going through, and he gets to PRD, a product requirements document. And my interest was piqued, and I was like, okay, let's see what this. So he basically said, this is a product requirements document. Here's the requirements, and then moves on. There was no conversation about what this is. One thing I noticed was it was a markdown file with a table, 4 columns, I believe, and all of the IDs were just sequential. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I said, okay, that's fine for a trivial project. What happens when that becomes a non-trivial project? Are you gonna have thousands of requirements? So it's gonna be 1 to 1,897 is what how do you organize this how do you organize these things? Right. So I think this is what the problem is going to end up being. We will use requirements to communicate to LLMs, and then we will say, just like we did with source control, by the way, this is why we don't sneaker net our patches back and forth.
Sneaker net. I haven't heard that one in a while. But for those of you uninitiated, sneaker net is where you pick something up on a thumb drive or a disk back in the day, a little floppy disk, and you walk it over to where it needs to go instead of
That's exactly right. Or heaven forbid, Linus receiving patches via email and applying them to the Linux kernel, right? So God forbid we have that again.
Right.
That is terrible. So we're going to have the same thing with requirements. We're going to have the same thing with prompts. So how do you manage when you start doing this at such a large scale? Right now, we're doing it these trivial BS apps that have like a handful of requirements. That is not how the real world works. So I think what's going to be really interesting is we're hopefully going to go back and we're going to pull from 30 years of software engineering experience, and we're going to go, oh my gosh, there was an entire field called requirements engineering that is basically prompts.
Prompt engineering,
And because once again, the reason it's called prompt engineering is, as we started off this conversation, we like to build things, and we're going to just, oh my gosh, we have to be specific about stuff that we write to the computer, and we're going to call it prompt engineering. We've done that already. We're past that point with the requirements.
So why are people? So okay, I'm gonna get up on my soapbox. Why are people okay with? Oh, we have to teach ourselves prompt engineering. We have to get so much better about telling these things to these computers. When us poor software engineers for decades have been saying, no, you can't just say, build me a checkout system. Tell me a little bit more about what you need. And they would throw their arms in the air and get upset about that when a human asks for clarity. But now that a computer is like, oh, here you go, and it gives the wrong thing, they're like, oh no, I need to learn. I need to do better. Why is it that they're willing to go the extra mile for a computer, but they weren't for us for decades?
Because they don't understand the connection. By the very nature that we have people talking about being specific in our English, they don't relate that to the fact of why we have this arcane syntax in our programming languages. It's the same reason.
Yeah.
It's because computers are morons. And we need to be very specific. Going back to the peanut butter and jelly sandwich example, by the way, for the audience, go look up the I don't remember what the title of the whole thing is, but there is a peanut butter and jelly specific requirements thing, and it's terrible. It's terrible to read, and this is what our future is going to look like for a little bit. They're not relating what they do on the day to day to now this English abstraction.
Yeah.
And I think that's really the problem. We have to be specific, which is why we have computer programming language, and the computer programming language history is all about increasing the abstractions. We went from flipping switches to machine code to assembly language to 3GL, and then finally 4GL. I mean, COBOL and SQL were meant to be used for business people.
Don't forget punch cards.
Oh yeah, I forgot. I did forget punch cards. That's right.
You forgot the punch cards.
So this is just another abstraction.
Yeah, absolutely. So requirements-based IDEs, I think that is something. I think that's going to be a ship. I think there's a there when it comes to, like, we're going to be spending an inordinate amount of time honing and refining requirements with these, even with these LLMs. That's going to be a big bulk of our activity going forward, is making sure that the requirements are sound and edge cases are covered and whatnot.
I think there's a bigger question in there, and that is, we've known about requirements for such a long time. Why do we not do them now? Right? And because we know, if I go to any programmer right now, and let's say this guy is an agile zealot, and I go to him and I say, build me a checkout system, and he's going to start asking me for requirements.
Yeah.
He can't just build, but I think there's this connection between requirements and the waterfall process.
Right. The R word is a bad word.
Yeah. Also, developers are not known for writing documentation.
No.
So subsequently, I think that requirements end up being this nasty form of documentation, because it requires you to sit down and think about the domain. And we've been told for such a long time that, well, you can't know all the requirements up front. And coming from the defense world, I can assure you that you can know all the requirements up front, given you have to be a little bit flexible during the project process. But you can get the big picture requirements very easily in the beginning. It's very interesting to me what I think the future holds for software development. I think it will add a level of professionalism that I think that we currently lack, because I do think that the industry is very unprofessional in how it approaches its production, its product production, its output.
Yeah. I mean, I can see why engineers, they kind of turn their nose at when we call ourselves software engineers. They're like, well,
Right.
come on now. If I do my job wrong, engineer, and a bridge falls down, you know what I mean?
That's
like,
right.
So
People
I have to
die.
have a level of rigor. It is built into my practice in that now.
Yep.
I'm trained. We don't, as you're saying, we don't have that level of professionalism or rigor in what we do. We're very sloppy in comparison. So probably shouldn't call ourselves engineers. I mean, even though I do. I mean, I'm not sloppy. Of course not. I rolled my eyes, by the way.
I still at this. I used to call myself a software engineer. I call myself a developer at this period of time because my job does not command the level of engineering I used to have to do. I don't have to write software requirement specification anymore or a software design document. Those aren't required for the contracts anymore. I thought we were going to talk about vibe coding.
Oh, yeah.
I thought you were going to ask me about that one.
I mean, you want to do vibe coding? Let's do it real quick.
I have a very simple quip. Okay. I don't vibe code. I'm a professional.
Yeah.
So I don't vibe code.
Okay. So you're a skip it then.
Yeah, I'm a skip it.
You're a skip it. But I think it's interesting when people talk about like vibe coding. Like, I think anytime you kind of interact with an LLM and it spits out any level of code, I mean, that's technically vibe coding. I don't necessarily hate the idea, especially if you're just saying, I'm going to say some stuff and take the code that it spits out verbatim and there's a run with it, YOLO it to prod. If that's what your vibe coding is, then I'm going to skip it. But I do think iterative working, like it was very helpful for me when I was writing my my side project, my library for doing neural networks. It was very helpful to kind of go back and forth on ideas and say, what do you think about this code? Oh, I think, it is helpful in that way. But as far as like just spit out the entire project and I'm just going to YOLO that to prod, I don't think that's a good idea.
That's when I'm on X or whatnot, looking at the people talking about vibe coding, that's what they're talking about, right? Is that I entered in or if you go look at the companies like Lovable being a specific example, V0, they just want you to enter in a paragraph.
Right. And then just accept what comes out.
That's terrible.
Yeah.
Absolutely terrible.
Yeah. It's funny. Maybe we'll accelerate the movie Idiocracy in the software development world faster than the greater population.
I am very much the get off my lawn sort of side of things on that. Like I am that old that nope, I don't want any part of that.
Gotcha. All right, so you're skip it. I'm skip it, like the YOLO to prod level vibe coding. I'm skip it as well. But I do find helpful. I do find it helpful to leverage LLMs to help mold ideas over time. It's kind of a good like pair programmer almost, right? Like a rubber ducking.
I've used it to find requirements that I didn't specify.
Mm-hmm. Yeah, what am I missing?
What am I missing?
Yep. That's a great prompt. All right, on to our most important segment of the show, the lightning round.
It's time for the lightning round. Rapid fire, don't slow down. Answer quick and make it count. In this game, there's no way out. It's time for the lightning round.
All right, so the idea here is we will give you some very important questions. These are like make or break questions for the entire episode. Like the answers to these will make or break the success of this episode for you, not me.
I will be determined to be a moron or a genius based on these questions.
Yeah.
Okay.
This
Can I just hedge my bet and say I'm a moron and be done with it?
you can, yeah. So you're shorting yourself there. Is what
that's 100%.
Okay. All right. So the answers to these, so they're very heavy. The answers matter, so you really don't want to just blurt out an answer. You want to put a little bit of thought to it, because it does. We're scoring. There's a whole process here.
Okay. All right.
Okay. So let's get into it. The real meaty part of this show. Name one of the 7 dwarves.
Sleepy.
We would have accepted any of the other 6 as well. What's your favorite carb? Bread, pasta, rice, or potatoes?
Bread.
Now again, don't feel like you have to
butter
blurt.
Delivery mechanism, by the way.
Butter delivery, yeah.
That's all bread is. It's for butter delivery.
That's what I call carrots is my hummus delivery system. That's
Sure, that's exactly right.
If you were given an all expenses paid trip to Cleveland, would you take it?
No, because I'm from Cincinnati and we don't go to the armpit of the Midwest.
Amen. Amen. That's actually what I had written down as this is the acceptable answer. That's you, verbatim. You nailed it. That's perfect. If there's a spider in your house, do you kill it or set it free?
It depends on how close to the door it is.
I think it depends on
So-
how much it surprises me. Like if it angers me, well, for the most part,
Sure.
I'll let them free. Yeah,
It's getting the boot.
yeah, exactly. What's your favorite clothing brand?
Whatever Target sells.
Whatever Target sells. Okay.
Yeah, I don't really look at the brands. If it feels good, then look at the brand, and then I go buy more of that.
How long can you hold your breath?
Oh, I haven't done that in a while. Probably 90 seconds.
It's not bad. That is above average. I believe the average is 72.6 seconds. And again, I made that up.
Okay.
Yeah,
all right.
but it sounded good at the time. Say a word in Spanish.
Hola.
Bien. Favorite junk food?
Cereal.
Cereal? You can consider that a
Yeah.
junk food? What kind of cereal are we
Yeah.
talking here?
Golden Grams, Frosted Mini Wheats. What else? Cracklin' Oat Bran. Oh, Raisin Bran, but Kellogg's, not the Post
Yeah.
or Kroger. But you got to have the 2 scoops because it's sweeter. That's my guilty pleasure is cereal.
I've been doing
With
this.
whole milk.
I'm on a Raisin Bran crunch kick.
Oh yeah, I don't do the.
I
Crunch
got the crunch. That's what I've been doing lately. Favorite city in the United States besides the one you live in?
Key West, probably.
Mm.
I used to live in Big Pine Key. I worked for the Boy Scouts. That down there.
Nice.
So Key West is really nice.
Invisibility or super strength?
Can I have both? Can't have both.
I mean,
Okay. I don't actually know. I don't know
I think in this world, if you have one, I would see it. It shouldn't be that hard to have the other. If you can already have one of them, like you know what I mean. Like if we're already going to this level of certainty, yeah, but have whatever you want, right? You can have laser eyes for all I care.
I would prefer speed, but I would probably take the strength. Yeah, the speed is. I find the Flash to be very interesting.
I think that's all of our questions. So, anything like closing
You guys got to
remarks?
bring harder ones.
And they're very important, right? So, any closing remarks? Anything to add? Things you'd like to opine about and share with the folks.
Yeah, I think that anybody who's listening, I'd recommend going back and looking at requirements engineering.
Yeah, I think that's
Start
smart.
getting good at being able to write requirements. RFC 2119.
The musts and the shall and
Yep.
yeah.
Yep.
Anything you're promoting? Anything like you have any side projects that you tell people
Yep.
about?
So right now I'm working on a requirements management system that's specifically going to tie into LLM. So actually right before a couple days before this podcast, I got the where I was happy with the minimum viable product. I've written a terminal project management or not project requirements management system. And so the idea there is going to be traceability. So that's the big thing, everyone, listeners. The big thing is traceability.
Like provenance of
Requirements
where did you get the idea to make this software do this and here where in the requirements, like where did it come from? Is that the idea?
All the way down to a given test case, all the way down to a given line of code. We should be able to, and I would make the argument that if we can do it in the technical realm, we can go all the way to business as well, because we're writing software not because the bosses like it, but because it meets a business goal.
Mhm.
Well,
Yeah.
what's that business requirement?
Somebody's got an
right?
OKR that they said, hey, we need some software to help me make my OKR, right?
And it's measurable. So the question the question starts to be is, can we apply requirements to business as well? And so and how do we measure that? How do we test that? Et cetera, et cetera.
Well, this has been awesome. Thank you so much for joining us today. This has been really great. Really appreciate having you on. And Mark Stahl.
Well, thanks for having me. I appreciate it. If anybody wants to reach out to me, X at mjstall0, and then Mark at technicallycorrect.company. That's the company that will be using the project. So you can reach out via email. And then 1millionmonkeys.substack.com.
All right. Well, this has been the /. If you'd like to get in touch with us, drop us a line at the /@calibrity.com. That's CALLIBRITY.com. See you next time. The / podcast is created by Calibrity. Our director is Dylan Courts, producer Ryan Wilson, with editing by John Corey and Jeremy Brown. Marketing support comes from Taylor Blessing. I'm your host, James Carman, and thank you for listening.